Good morning, everyone. Today we're going to move on and we're going to use the cosine law in a little bit different way than yesterday. So just as a reminder, last day when we were introduced to the cosine law, we were using that to find the side length of a triangle when we weren't able to use the sine law. Well, what we're going to do today is we're going to use the cosine law, but we're going to use it to find angles. So if you recall yesterday, in a triangle A, B, and C, and this would be side B. If you wanted to find side B because you had side C and you had side A, so let's just make up some numbers here, 5 and 7, and you had angle B, let's just call it 50 degrees. When you had two side lengths in a confined angle, you were able to find B. And the sine law that we used was B squared equals A squared plus C squared minus 2AC cosine B. Well, what we're going to do today is we're going to use that to find B. Let's say we didn't know what B was, or what angle B was, but we do know what side B is. We can rearrange this formula to solve for angle B. And in rearranging, what we want to do is we want to get this, the cosine B, on its own. So in rearranging this formula, my A squared and my C squared are going to stay right where they are. And I want to move two things initially. I want to move the B squared to the other side of the equal sign. And so that positive B squared will become a subtract B squared. And I'm going to move, I can't just move this cosine B on its own. So I'm going to move this entire thing right here. This is a minus 2 times an A times a C times a cosine B. And as long as I'm not breaking up these multiplication bonds, if I just move this whole thing to the other side, it becomes a positive 2AC cosine B. The last thing I'm going to do to get cosine B on its own is I am going to break this bond right here. So we'll be left with cosine B, and on the right side we have all this. This is a 2AC times cosine B. So when I move it to the other side, it'll become a divided by 2AC. And there's my rearranged formula. This is a skill that you want to make sure that you know how to do. The biggest complaint that our science teachers have in grade 11, our chemistry teachers and our physics teachers, is that students have difficulty rearranging formulas. And this is such a huge part, especially in physics. So if you are competent at rearranging formulas, you'll have a much easier time in physics and chemistry next year. So there's our rearranged formula. And of course, we have several different versions of it. We could have cosine A, and that would be B squared plus C squared minus A squared over 2BC. And likewise, if we rearrange for C, we would get something like this. So what we're going to do today is we're going to find a couple angles using our rearranged cosine law, and that'll be that for today. So let's start with a triangle. This triangle I'm going to call TKW. This is side W, this is side T, and this is side K, opposite the angles. In this case, I know all three side lengths. I know W is 5.2, I know T is 6.4, and K is 7.3. We're going to use our rearranged cosine law to find our three angles. So let's start with, let's just find K. So to find K. So I'm going to use our rearranged formula. And so cosine k is what we want to find. And that would be t squared plus w squared minus k squared all over 2 times t times w. Cosine k would be, subbing in now, t is 6.4, w is 5.2, and k is 7.3. And so 2 times t times w. And now let's simplify this. So cosine k, 6.4 squared is 40.96. 5.2 squared is 27.04. 7.3 squared is 53.29. 2 times 6.4 times 5.2 is 66.56. Continuing to simplify, on the top, we get 14.71. Divide those up, and we get 0.2210 rounded to 4 decimal places. We want to find k, so like we've done for the last couple of weeks, we're going to use the inverse function of cosine. And let's round these to 1 decimal place. We get 77.2. So angle k here is 77.2 degrees. It's really as simple as that. It's just plugging in our the numbers into the formula and going with it. Let's find angle W. So to find W, we'll use our rearranged cosine law formula. So cosine W is equal to t squared plus k squared minus w squared times 2 times t times k. Putting our numbers in. Sorry for my messy writing here. I'm trying to write around this thing that's holding my camera. So I don't know if it shows it, but my wrist and everything's at kind of a weird angle. Simplifying all this, on the top we would have 67.21. On the bottom, 93.44. Cosine W would be 0.7193 rounded to 4 decimal places. W would be the inverse function of cosine. And I think we get 44.0. That's rounded to 1 decimal place. So W here is 44.0. If you want to use a cosine function again to find angle T, you can. While that's a lot of fun, I prefer just to do things the simple way. So to find T, I just use our 180 rule. 180 degrees in the interior, 180 interior degrees in a triangle. So minus the 77.2 and the 44 that we've already used. I believe that leaves us with 58.8 degrees. So we have 58.8. That's it. That's as hard as it is. All right, let's do one more question. We'll do a word problem. And then that should be it for today. So here's our question here. At nighttime, a security camera pans over a parking lot. The camera is on a post at point A, which is 53 meters from point C and 71 meters from point B. We have a distance from B to C, and we have to calculate angle A, the angle through which the camera pans. So let's draw this up. All right, looks like something like this. So we have a post here, and the camera on top. And that camera is at point A. The camera can see point C, and we know that it is 53 meters away. The camera pans or turns, and it can see all the way over to point B, which is 71 meters away. And we know that the distance between these 2 points, B and C, is 68 meters. So we have 3 sides to the triangle. And this question is asking, what is this? What's angle A? How far does that camera pan? So that the camera is looking from left to right, moving back and forth. What's the degree of the movement? So because we want to find A, we'll use or angle A, we'll use our rearranged formula. Now a reminder, this is side A, opposite angle A. This is side C, which is opposite C, and side B. It's a great idea to label those up just so you don't make mistakes as you're going through the math. So our rearranged formula here, since we're trying to find cosine A, we'll use our cosine A. And that's equal to B squared plus C squared minus A squared all over 2 times B times C. Cosine A is equal to 53 squared, so that's B. C is 71 squared, and A is 68 squared over 2 times B times C. Cosine A is 2809 plus 5041 minus 4624. And we'll divide that up by 7,526. Continuing to simplify, we get 3,226 on top. And cosine A, divide those up, rounding to 4 decimal places. We get 0.4286. A would be use the inverse cosine function. And we discovered that that camera has a 65-degree range of motion. So that's it, ladies and gentlemen. Do your homework. If you have any questions, please send a message off to me. Some of you have. I quickly write up a solution for you, and I can text you that picture back. So if you're wondering where you're going wrong. If not, if you've been understanding this all along, you shouldn't have any huge issues with this. Just make sure that you're putting the right values into the right spot. And as long as you're not making a computational error, a 2 + 2 = 5 type of error along the way, you should have some success with this. Have a great day, everyone.